a huge thing with the tests. I don't know what it is. I can do really well on assignments and projects, but the minute you put a test in front of me, I don't know what it is. I just don't know what it is about tests.
There's a lot of people like that though, Katrina. That's very common.
I think I just get too frazzled when I know that I'm being tested for something. Even though if she was to sit down with me and I was to say, oh, I understand this, I get this. I hate this.
And making our pictures bigger.
Do you want me to change the names on the front page to match the pictures?
Well, I did this because our pictures are a little further away, and yours is more close up, so I put yours in the middle so that it evened it out. Do you know what I mean?
Yeah.
There we go. All right, now I need to back up
the names around. Okay. Do we have any, anybody have questions about the preparation?
Okay, let me go over.
What did you guys write for number 1?
Hold on one second. I'm not looking at it. I'm just finishing up getting our, what in the world?
For number 1, all right, let me get there. Are you there, Shelley?
Almost. I'm just getting our names put back into place. Tammy, what are you doing?
Leaving my name down.
Yeah, but that's where I was at. Now you're
I
putting
didn't
me
see
in.
your line there.
Yeah.
Katrina's needs to go up just a touch.
Okay, hold on one second. I'm getting that one.
What are you guys working on right now?
The slide, because we took Michaela off.
But on page 1? The first one?
No, I asked you.
sure.
I asked about number 1, but Shelley's not there. She's still in the slides.
All right.
Oh,
The picture.
well, I'll answer. I put a way to write an equation to show relationship between X and Y.
Okay. I put down what the guy said on the tutorial, that it was an equation that represents a line that represents your data. And I said, we use it to predict a measurement beyond the data given.
Which does, that does explain the relationship between X and Y.
Okay, because when you draw your line up, you can go up that line and then find your measurements beyond what the data it already is, if that makes sense.
Right. So that lets you know if it's positive and if it's, if it's heading in the same direction. So
anyway.
Okay.
So
I thought the preparation,
questions?
No, I thought the preparation was really easy, and I even felt that the homework was easy, except for number 16 on the homework.
Okay, I haven't gotten, let me look at the homework in just a second. I had a problem with number 13.
Okay.
Because it said for the observed head length of 51, what is the observed body length? Okay, they could have worded that so much better that said, go to your data in SPSS and find one that lists 51, and tell us what the body length was.
I did not figure that out until I watched the actual tutorial video.
I didn't either. And the tutorial's like messed up. They jump around. You have to go way to the end to find out how he did it.
I have to proudly say I figured this one out before the tutorial. This is probably the only time I can ever say that, so I have to say it.
Yay! Where were you when I was trying to figure it out last night?
I just figured because I just thought, I should just go and look at the list for the head length and find 51.
But you know what I think is weird is that they didn't have us do any more observed throughout the homework.
Well, I did what they taught us in the textbook is I put 51 at the bottom, and all I got was the 308 number, and I'm like, okay, so this is really frustrating. Where are they getting 343? And I couldn't do it. Yeah. So anyway.
Well, should we go ahead and do the quiz then?
No. How about homework? We have to go to the homework and look at number.
Okay, I have to make sure I'm on in 40 minutes.
You're what?
I have to make sure I'm done in 40 minutes because that's when the review session starts with her.
Okay. All right. So let's do. Did you do your homework, Shelley, yet?
Mm-hmm.
So Katrina had a question 16.
Yes.
Okay,
this is the one that we always have problems with, and we always get different answers.
The covariance.
You know how you have to
the SPSS answer.
Yeah, but that one is like a major big number.
That's okay.
Like, okay, because you take the mean, right? Aren't
No, standard deviation.
Gosh.
I made that, actually, Katrina, I made that mistake and I had to go back and look at my stuff because I kept
So it's-
calculating the different means and it's the standard deviations you're supposed to be calculating.
So the two standard deviations still, because I did that number and then I thought, okay, that doesn't match up. So then I went to the mean and that didn't match up.
Yeah, it's the
Couldn't figure
standard
out
deviation.
why their number is so low compared to my number,
So I had 0.99
right?
times 9.657. Did you have that?
I don't know. I don't have the graph up right
Oh,
now.
okay. And then I did times 74.731. And it gave me exactly what they had.
Really?
Mhm.
All right. Maybe I
Those
need.
are my two standard deviations, the R, right? Plus the two standard deviations, and I got what they had given.
You got it. Well, then I obviously did something wrong.
I did not do the last set in my homework last night. I only got to number 12.
Well, how about we do the homework? I mean, how about we do the quiz, and if we have time afterwards, can we go back and see what I did wrong?
Okay. All right.
Because that way we'll have time and you won't have to miss the review. Does that sound good?
That's fine with me. And I can go over homework with you because I still have to do 13 through, what is it, 19? Yeah.
Well, we could have plenty of time to go over it, but if we could just get the quiz done so that I'm not behind the eight ball on time, that'd be
Stressing
great.
over that.
Well, I got everything else on the homework right. It was just this one, trying to figure out what I'm supposed to.
Katrina, I did that equation 3 times before I figured out I went back and looked and found that I was doing the wrong numbers. You should see my sheet. It looks horrible.
Well, you got the right answer, so that's good.
I kept erasing anyway.
Yeah.
All right. And there's one data set we're going to need.
Shoot, are we in 22 or 21?
22.
22.
You
Okay.
already did 21.
I labeled this as 21 in the YouTube.
Oh, well, you probably can go in and check it, or change it, or just put it in the notes.
Yeah.
Okay, so I am in the quiz.
Alrighty. Here we go. Given the linear regression equation, y equals 2.0 plus 1.5x, what is the y-intercept?
2.0.
2.0 number.
I agree.
Oh, yeah.
These ones are easy. I like this. What is the slope? 1.5. You agree?
Dang it. I keep getting kicked out of the stupid page.
Okay, we're gonna have to do this.
Now we're
equation.
doing math.
Yep.
Negative 2.
All right, y equals negative 3.025
I get 1.
times 16. Okay, I gotta go to my little calculator. Are you back in yet, Tammy?
Yes, just got back in and I'm starting number 5. So
Okay.
given the linear equation, negative 3 plus 0.25, what is the predicted value of y when x equals 16? Okay.
Zero.
Did you guys watch the crocodile movie?
I watched the 15-minute part.
No, should I have?
It was quite
I have-
interesting. I can't
wait.
believe how big they were.
You got one?
I got the answer of 1, which doesn't really make sense because it's
I got 2. Hold on, let me do it again.
negative
Oh, you're
3.
right. I put it in wrong.
I'm bringing out my calculator.
I did it wrong.
Yeah, I keep getting 1.
Yes. That's what I got, 1 as well. What is the predicted value of y when x equals 16? 1. What did you get, Tammy? Are you still doing it?
I'm just typing it in. So 3 point plus 0.25 times 16.
Yes.
Okay, I got 7, so I'm going to do mine again.
Wait, did you put negative 3.0?
Nope.
Negative 3.0.
Okay. I get 1.
Yeah.
All righty, we're good then. Okay, we got to pull up the SPSS of math self-efficacy. And we
Oh,
have
confidence
to-
and score.
what do we have to do?
Okay.
Are we doing a scatter plot? Yes.
Yeah, I've got to copy and paste mine over to SPSS real quick.
Okay, so I have to read the question because I have to know how to put it over. Move the scatter plot of the 3 data shapes introduced in the reading. Which shape best describes these data?
Okay, that means I need to go back and read what they put in here because Shane Goodwin and other researchers studied factors that affect. Oops. You way too far over. That affect a student's confidence on a multiple choice mathematics exam. A group of 139 students in an intermediate algebra course at BYU, Idaho participated in the study. The exam consists of 30. For each test question, students evaluated their confidence in their response.
Okay, so what are we doing? Let's see, the X is going to be, where am I?
That's what I'm trying to figure out, but
Well, the explanatory is going to be confidence. So that's the X.
How do you know that? Where does it say that?
Well, on the top, it's when it says for the next 7 questions, use the data file.
Okay.
Be sure to use the confidence data for the explanatory, so that's X. And the score as
Okay.
oh, yeah, I
Okay,
totally
or
missed that.
Be sure the confidence data for the explanatory variable and the score as the response variable. So the
Yeah,
So the X is the score. No. Hold on. Did I just say that backwards?
X is confidence and the Y is the response or the score.
The
Yep.
X is the confidence. Whoops.
and the Y is the score.
Is the Y.
So once over the hot dog shape, hamburger shape, or banana shape,
Okay, mine's pulling up right now.
really?
This one does not look like. I would say more, I guess if I had to guess, a more hot dog because it just kind of goes.
Yeah, I would think so as
I mean,
well.
it doesn't have like a curve to
It's
it.
not a curve. I don't think so either. I would say hot dog as well. Tammy, do you have it?
I'm getting there. I did my other stuff first.
I mean, a hamburger would be the entire screen, which I don't think that that is what it's showing. So why do they make these so hard?
To me, it's a hot dog. It's definitely positive. It's definitely linear.
I would say it's moderate though.
Yeah. But it's a hot dog. It's not a banana. It's not curved and it's not round.
Yep.
So for number 7, it's going to be,
Hot dog. 6 is hot dog.
yeah.
Based on the shape of the scatter plot and what can you say about the appropriateness of using a sample linear regression? Simple linear regression is appropriate for these data?
I think it's appropriate. It's
I do too,
positive.
because look at the numbers. They're all positive.
Yeah, I would say it's appropriate.
You've got 18.690 and 12.695.
So it'd be the first one for 7.
That's what I say.
And number 8 is how many observations are in the data?
Where's N?
Sorry, I'm using one computer today, so I don't get to.
Okay, I'm trying to. Okay.
139.
Okay, hold on.
Yes.
Where are you guys at?
If you look at just the front page where the data is at, it says that they had 139 samples. Or it says comments, it says a group of N equals 139 students.
Oh, I just scrolled down and looked at 139.
see, I'm trying to find mine.
Okay, so if you look in the ANOVA, it's the total is 138.
Right, that's what I saw. I see 138.
Wait, why do you have a NOVA?
It pops
Oh,
up when
I
you do
see.
your linear regression.
I see.
I don't see 139, I see 138.
Yeah, let me
Oh,
look at
why
the
is
front
that?
page. According to the data set, there's 139.
Because mine's only showing total 138.
That's what this shows too. Why is that?
But then when you look at the statistics, it'll say the number is 139.
Okay, so actually go to the data page, the one that lists all the data.
Okay, let
If
me
you
go
go
back.
down, it
And you
goes
scroll down and there's 139.
Are you counting the first line, which tells you the names?
No, it starts at 1 when you're getting the gender and the score
Yeah.
already.
That is true. So I would say 139.
Wait, oh, yeah. Well, if you look at the data also, it does say under N is
Right.
139. So
Yeah.
it's, okay, so 139.
The y-intercept is 18.69. You agree?
Let me go back and look at mine. That's on the graph after you have put the line through it.
No, it just says it under the coefficients box.
Okay, hold on. Coefficients box.
The constant is the y-intercept and the rating mean is the slope.
So what number did you get?
I got 18.69 for the y
Okay.
and 12.695 for the slope. $12.695. Yeah.
Yes.
Now we need to do the equation.
Yeah.
What is the predicted value of y? So we just times, don't we just take the 18.69
Yep.
plus the 12.695 times
4.
4. So 69,
47.
69.47.
That's what I got. Did you get that, Tammy?
I'm working on it.
Okay.
69.47.
Yep.
All right, buddy.
12, the confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y? Values of x.
Because there's a positive correlation, we can use the largest x value to find the largest predicted value of y. Okay, so we need to go to the data set. And we need to find the largest, what did they say?
You know,
The
I
largest
hate when they
X
put stuff
value.
on the test that they don't give in the homework or the,
I have no clue what they're even asking for.
Well, the so why it says, because there's a positive correlation,
All right.
you have a positive numbers, we can use the largest x value. So we need to go in here. What do we use for x? Is it the score? I get these confused.
The x1, oh shoot. We used x as the confidence.
Okay, then we go through, we need to find the largest confidence rating. And it says to find the largest predicted value of y. So I would,
So we need to go down that list and look for the largest number and then go over and see what the score is.
I think so.
Well,
6. Largest one I found is 6 so far.
score data as a response. Y is the score. All right, so they want to know.
yeah, I saw the 6. I don't see anything larger.
96.70. but there's two of those. And the largest out of the two I found was 96.70.
Is both of them not the same?
Mm-mm.
How could that even be? If
What
they're
is
both
the
the same number.
value of y for these values of x?
Yeah, the largest number I saw was 6 also. $96.7.
I hate only having one computer. I have to like open and close so many things.
Yeah, welcome to my world. And I have to cut and paste from Excel over to SPSS. I'm guessing that the answer is going to be 96.7.
So wait, we have to find, they want to know what is the maximum predicted for y for these values of x. Stupid computer. What's the maximum predicted y for these values of x? So we have to go to the largest x value and find the predicted y.
And the largest one we found was a 6.0, and there's two of them. And the largest out of the two is 96.7.
Yeah, my computer's not working. Hang on. I've never had this trouble. Okay, here we go. You found 2 6s? There's one.
Weren't
I
there
saw-
2 6s?
I saw 1 6. Nope, there's 2 6s.
2 6s.
Yeah, there is, because the other one's 93.3. Which is so weird, because I don't understand why the
Yeah, there's two. One has 93.2, the other one is 96.7.
96.7.
But as you're going down, you'll find the 96.7 first.
But it doesn't really matter. You just do the score times 6, right?
No, you just look over to the other column to see what the score is.
Oh, well, those aren't predicted. Those are actual datas.
But they're
Oh.
saying, what is the maximum predicted value for of y for these values of x? And it says, hint, because there's a positive correlation, we can use the largest x value to find the largest predicted value of y.
Okay.
Or does that mean that
Oh,
we're,
you know what? Actually,
are we
you know what I think
putting
it means?
that as the x and doing the equation?
I think it means that.
Do we do the equation with that as the x?
Well, do you know how you had to go in and change SPSS to bring up that third column of?
I'm going to do that right now, and we'll see
And
what
wouldn't
happens.
the highest score be 100%?
But this is, yeah, but it's not saying what the highest score is. It's saying you find the largest x value, which is the confidence rating.
Okay, so if you do the SPSS and put 6 in, it's 94.859.
And that with, if we put it in that equation, you're saying?
Yes.
Yeah, because you have to go into the predict. If you pull up your
No,
SPSS.
if you put it in SPSS, if you put 6 under the confidence rating and save it, it brings up that extra row. Sorry, you guys, my hips are stuck. I need to crack them. If you put 6 in the confidence rating and save it, you get the 94.859 off into the new column. That's the prediction.
Right.
Okay, and you said it's 94 what?
94.859.
Okay, and I'm sorry, tell me how you did that again.
Okay, so in your data set, go to the bottom of the confidence ratings and put in 6 in line 140.
Oh, okay, hold on. Oh, okay,
And then you go up to analyze,
analyze.
Don't you
regression,
have to highlight everything or no?
linear. No, you don't. Linear.
Okay,
And then go to save, because your score should already be independent and your confidence rating should already be in your independent.
okay, I hit save.
So hit save and then hit the unstandardized box and say and continue. And then hit OK.
Okay,
And then, so way down at the bottom, if you highlight line 140, you don't have to, because in this case, you can see it easily, but sometimes there's so much data that you can't see the extra row. That's when you would highlight, just so you get the right line.
Okay.
So where you see the 6 in line 140, if you look over into your new line, that's the prediction line. Your highest number is 94.859.
I don't have a line there.
You don't have a third column? Right
Okay,
next
so
to it?
we did something wrong. Go back to analyze, regression, and linear.
Mm-hmm.
Okay, now in the middle, there's a save box.
Yeah,
Hit the unstandardized, check it,
it's checked.
and then hit continue,
Yep.
and then hit OK.
Okay. And it takes me to where my graphs and everything are.
Oh, just go back to the other.
Go back to your data.
Okay. It's still just a 6. Am I putting a 6 in the wrong place?
You should put it under confidence rating.
That's where it is.
So is there a column next to it that says pre-1 with a bunch of numbers?
I'm looking to the wrong side.
Yeah, you don't want to look under
There it is.
score. You want to look under the
Yeah, it was too far over. Okay, we got it. We're good. That's awesome.
94.859.
Yep. Okay, thanks.
I think that should be the number for 12.
I guarantee it is, because it's that's what they showed us how to find a predicted value.
Okay, how many explanatory variables are present in simple linear regression?
Well, that would be more than 2, because you have to have.
How
More
many
numbers.
explanatory independent variables are present in simple linear regression?
Are they talking like, isn't it just one? Because you have one explanatory and you have one responsive, I thought.
Yeah, they're not asking the question very good, because are they talking about the whole data set, or are they
That's
talking
what I
about
thought.
just one equation?
I don't think they're talking about the whole data set if it's more than 2 or 1 or 2.
It says how many explanatory, which is the X value. How many
Independent variables? And I think it's just one.
present in a simple, I don't know, because the graph is a simple linear regression. You
But
have
so is the equation.
but don't you have to have more than one to?
That's why I say they didn't word it very well, because
Read the question.
they're not saying, is it the equation, or are they talking about the whole graph, the data set?
Read me the question.
How many explanatory variables are present in simple linear regression?
Well, it's either going to be 1 or it would be more than 2.
Oh, it's 1 because it's simple. For more than one explanatory variable, the process is called multiple linear.
So a simple one is just 1.
Yep, that's from what I'm reading. Because when
And
it's
so
more
the
than one,
next
they call it
question, number
multiple.
14, is how many response-dependent variables are present? And that would also be 1.
I would think so, because
Yeah.
it's simple.
Simple.
Because we're doing simple.
And then 15, a company in South Dakota manufactures hard hats used in the mining industry. They recorded measurements on all the hats they produced for quality control. The measurement they collected included hat size, circumference, and the lengths of the major and minor axes, meaning the company wants to predict sizes of hat given in the circumference. What is the response variable? So
It'd be the size. The size of that.
This is in homework.
That's the idea.
Okay, so
Because we're trying to predict the size of the hat, so that would be the Y. We already have the circumference, so we're trying to predict the size. Makes that the response.
okay.
Yep, it's
So-
the first one.
This is the variable being predicted.
Okay, I'm going to go ahead and submit. Thank goodness we get more than one.
Yes.
Did we miss anything?
I don't know. I'm going down. Nope, we got them all right.
Sweet.
Yay.
Nice.
Okay. When do you guys take off, Shelley? Oh no, you're not traveling today. You just have to go to that class.
Right.
Okay.
Right.
Well, I only have one
Okay,
question
so
on the
let's-
homework, so.
Well, if you want, we can start to do that because I still have about 14 minutes.
Okay, and if you
So
wanted
let's
to
do that.
show me where to find that, I'm gonna pull up all the data real quick in SPSS.
Okay. I'll pull it up too and then just do my homework. Okay, so the homework that you're looking for is the equestrian crocodiles modified.
Yes. So we're trying to predict the body length, so that would be the Y, to the head length.
So once you pull that all up and you do that, Katrina, tell me what your standard deviations are.
Oh, it's not letting me pull up this. Oh, what is going on? Hold on, I'm trying to pull it up onto Excel and it's,
So do you use jeans?
I really should have just purchased SPSS.
Yeah, but you just don't know that until you're into it. I only did it. I was not going to purchase it, but I could not get my, okay, so mine isn't working either. I have to close out of SPSS and come back.
I can't pull up anything anymore.
I only bought it because I could not get the other one to open.
Well, I think that they should just make it as part of the class.
Yep, I
'Cause
agree.
it's been a nightmare.
You need me to
Oh, good, I got it. Okay.
put together?
No, not all. Yeah, not all.
Okay, so the question is, we've got Alright, so the question is create an intelligent scatter plot of the head compared to the body length, include linear regression. Okay, so
What?
I have one open hanger, so you want hung up in the garment bag? She's gonna have stuff out.
I don't think so, other than what I had, unless I put like my jeans in there, but I don't think so. Everything should fit in the suitcase.
So the body length goes in the Y and the head length goes in the X.
No,
Yes.
your head should be X, your body should be Y.
That's
Yeah.
what I said. I
Yeah.
just said it backwards.
Okay, well then.
I just said it. I said the Y first instead of saying the X first, but I said them correctly.
I thought you had said X was body, but okay.
Okay. Okay, so I've got the data pulled up. And now I need to figure out okay, so now I'm looking at standard deviation, not
What's your,
the mean.
What's your standard deviation?
Okay.
Your X standard deviation should be 9.657, and your Y should be 74.731.
I am not seeing that on here. Let me,
Did you go through and do the bivariate?
yes, I did. Which one would it be under? Coefficients?
Hold on, let me.
Why am I not seeing those numbers?
Did you hit the means and standard deviations box under options?
Oh, let me look.
Oh, that's probably why you're not seeing it.
Under analyze,
You have to
Analyze,
go in.
correlate, bivariate, and then go to options.
you know what? That was my problem. I did not do that.
Okay.
Compute the sample correlation efficient, which is 0.990.
Right.
Describe the data displayed in the scatter blocks. Does it appear linear, positive, and strong?
Okay, I
Compute the
just,
sample covariance of the data. So that's 0.990.
right.
And then do you have your standard deviations now? Do you see them, Katrina?
No, I'm still looking for that one. I just did the, oh. Did I
You
not
have-
do it all the way?
See yours, Tammy?
I see mine. So Katrina, since you did it later, yeah, you'll find it way down at the bottom.
No, I just didn't click the box under means when I went into the,
Okay.
okay, here we go. I will get this. Okay, so yes, I do. 9.657 and 74.73.
One. So if you times all of those, you'll get the answer that.
Oh, that was my problem. Okay, I gotta make a note. Okay. Yep, that's all I needed help with. Thank you.
Sweet. I'm gonna have to go on and do the homework quiz tonight.
I do too. I have a baby waiting for me.
Oh,
All right, I have to go. I have to really quick pack the rest of my bags because we're going to a different hotel tonight.
okay.
You-
Thank you for
See
your
you
help.
guys.
I'll post it for everybody to comment on.
Okay,
Okay.
thank you.
Thank you.
Bye.
Bye.
Have fun, Shelly. Hi, little one. Did you sleep in here last night? To stop the broadcast.